So again, thank you so much, everyone, for joining us today, and happy International Moon Day. So for those who don't know us, we're co-founders of SpaceBase, and SpaceBase, Eric will talk about it in a little bit, but I just wanted to point out that SpaceBase is also a member of the Moon Village Association, which is based in Vienna, Austria, and Eric is actually the country rep for New Zealand. So I guess without further ado, I'm just gonna turn it over to Eric and take it away.
Yeah. Hi, welcome everyone. I will start sharing screen here. Let's see. Here we go. Yeah. So I'm. This is Fly Me to the Moon. It's for International Moon Day, which is actually the 20th of July, but since with the time zones in New Zealand, the anniversary of the Apollo 11 landing happened today, this morning. Let's see. So a busy slide about my background. I started in physics and astronomy, mapping the galaxy, went into space engineering, working with NASA on the space station design, and working for big companies, Lockheed and Raytheon, and lots of working with small companies, starting space startups in California. And then through International Space University, I've been on the faculty for about 14 years now, and teaching in 10 countries. I also should mention that for International Space University, I was a team project chair earlier this year for a group looking at the future of human habitation on the moon, with 19 participants from 12 countries. But Emily and I came to New Zealand about 6 years ago as part of Informed SpaceBase, focused on helping countries around the world get involved with space activities, and starting focused on New Zealand at first. And the main aspect of this is to use space technologies for the benefit of Earth, looking at addressing major global issues on Earth with space technologies, and including currently we're inviting applications to our Space for Planet Earth Challenge 2023, which is focused on detecting methane emissions on Earth using satellite data. And so methane is one of the major contributors for climate change, global warming. And so we think people have an opportunity to, if you can address this problem, you can really play a major role in addressing climate change. But while we focus on using space for addressing Earth problems, we're also interested in the expansion of humanity out into the solar system, which is the what we're talking about today, with the especially developing the moon and returning to the moon with humans and large-scale activities. So this is just a snapshot of the moon with where we always see the near side, and only through satellites do we see the far side of the moon. They actually it looks slightly different. They have the dark Maria flat lava plains on the near side, and not on so much on the far side. And this is just a picture of the scale of New Zealand and on the near side of the moon here. So if you looked at, occasionally with spacecraft, interplanetary spacecraft, we have images of both the Earth and Moon together. And these real images illustrate how dark the moon is in comparison to the Earth. the full moon seems very bright to us, but if you were on the moon looking at the Earth, the Earth would be 30 times brighter than the full moon. And so that's what really dazzled the Apollo astronauts as they went out to the moon and they looked back at Earth. They were just amazed at the colors and brightness of the Earth. With the distance of the moon, this shows the scale, the images, the scale. We're actually to the point where it's more than a light second away. And so if you were having a Zoom call with someone on the moon, you would definitely notice the time delays in the communication. Then if you were, every time we see the moon with a certain phase, if you were on the moon looking back at the Earth would have the opposite phase, and the Earth would be rotating every day underneath that, within that phase. And so you'd also see the continents, and you'd also see the lights of the cities from on the Earth from the moon. I'm going to talk about the past and the present and the future and the long-range future in this talk. First off, with the past missions, before the Apollo missions, there was a flurry of space missions, both the U.S. and Soviet, that were preparing for the landings of the human landings on the moon. As you can see, all these different surveyor missions, in the Soviet Lunar missions that were landing, and then most recently the Chinese Chang'e 3 mission there. And I think there's this, you basically have this pattern where you have a robotic mission and then you have human missions that follow. And so I love this picture of Apollo 12 visiting the landing site of the Surveyor that had landed about a year and a half earlier. But in the history of lunar exploration, after Apollo, there was a long pause where we kept going to Congress and begging for more lunar missions, and that never happened. But Japan, Europe, China, India, they started flying orbital missions. And there is this, and there also is a US lunar reconnaissance orbiter that launched in 2009 that's still operating 14 years later. And so that's where most of the maps of the moon come from. But Apollo, there were just 6 landings on the moon during the Apollo time. And this is a picture from Apollo 11. It's kind of interesting that Apollo 11 was, they wanted to focus so much on just landing and getting away safely that they stayed almost within the range of a tennis court from it's about as far as they traveled. And this is a big contrast to the later missions where they explored quite a bit more. Apollo, of course, was a enormously complicated mission in the 1960s with the combination of the command module and lunar module to land on the moon, and there's all these detailed steps of being able to go out to the moon, land, rendezvous in orbit, come back. And if you were an astronaut on those missions, you only had a small volume to stay in. You had your main seats there, and you could crawl underneath the seats or behind them. And 2 people could go into the lunar module and for a landing down on the surface while one stayed up in orbit. But it was basically if you are going in a regular trajectory out to the moon, it's 3 days out to the moon. Apollo enabled you to stay about 3 days on the surface and then 3 days to come back and land in the ocean. Here are the Apollo landing sites. The 11, 12, and 14. 13 had a failure on way and had to swing around and come back. But you can see that the initial missions were all near the equator, and they thought they could only land near the equator, but then later on, they realized they could design things so that they could land farther north or south. And so 15, 16, and 17 were the more complicated missions, landing in the mountains in the lunar highlands. Here's Apollo 15 that landed near this mountain. All these mountains look very rounded, but they're actually, this one is like 4,000 meters high. And so they're really tall mountains. It's just the erosion of over billions of years has just made them smooth like this. And the later missions, you had lunar rovers, so you could a vehicle that could fold out and drive you around the moon. So here you have it's a sped up video, but you can see that the efforts that the astronauts had with their very heavy suits, and it's interesting, they could never tell the distance very well. They would approach this one rock thinking that it was a small rock, and it turned out to be the size of a house. It's just the no atmosphere meant there's perspective is very difficult on the moon. And you can see this is a funny compilation of all the times they were falling over with their spacesuits and EVA suits that were like 80 kilograms. So it was very difficult to move and bend over and get themselves around. With the lunar rover, they actually were able to travel up to like 10 kilometers away. They never wanted to go farther than they could walk back if they were in trouble, and if the lunar rover suddenly stopped working. So they did a lot of exploring, but they also were always conscious of needing to be able to get back to the safety of their lunar module. This is an illustration of how far they've managed to travel with these. I centered it on the Zapapa Museum in Wellington, and so you can see that they got the equivalent of driving around about as distance of the Wellington Harbor, but that's the extent of their surface exploration on the moon. And this just zooms into the Apollo 17 site from the lunar orbiter images to show the scale of their explorations in this valley among these mountains. So if you zoom in farther, you can see the actual lunar module, the base of the lander that remains after the top part took off and brought the astronauts back. And you can see the tracks of the rover and where they drove. Now, one thing that was learned during Apollo that was not known before they brought samples back was that the realization that the formation of the moon really started with a giant impact. Only less than 100 million years after the proto-Earth formed, it was hit by this object, this other planet, almost the size of Venus, of Mars, and so and the crust of the proto-Earth got blown off and formed the moon. That's why the moon is very similar to the crust parts of the Earth. And this is just a recent supercomputer simulation of the impact. That realization that the accumulation of what became the moon happened, in a very short time, in days, in order to before the it's a different perspective from the theory that thought that this happened over millions of years. So here we have an amateur astronomer is taking images of the moon and stretched the colors so that you can get so the subtle grays have started to show browns and blues that the colors are real. They just have been enhanced in the processing. but you can see that there are some areas that are bright white, like the Tycho crater, or this area that's also known as a very bright object in the Maria. But the blues and browns are indicate some of the titanium and iron oxides that are in the lava plains on the Maria. If you measure the altitude of these different regions, the moon actually has some very different altitudes. There's the flat lunar plains of the Maria, but then there's on the far side, there's these highlands that are actually as high as the Himalaya mountains on Earth. And then you have this basin that's the largest impact structure in the solar system that is deeper than the deepest ocean trench on Earth. The moon is covered, of course, in craters and from impacts from most of them being more than a billion years old. And it's remarkable that all these mountains on the moon were formed. If they're formed to be by impact, they're formed in a matter of minutes, in less than an hour. And if you just imagine a giant impact that will make molten the entire surface and have the mountains spring up suddenly. And this is one of the more recent impact craters is the Tycho crater. This about 100 kilometers across. So all this entire massive structure just was created in less than an hour, and it's frozen in place in billions of years. I mean, actually, this one's 100 million years, and the boulder at the center on the top of the structure in the center is about the size of the Tapapa Museum. And the interest in the moon has been focused on the polar regions, especially the South Pole of the moon, because the North Pole has lots of jagged mountains and it's going to be difficult to get there. But the South Pole has a lot of combination of mountains and deep craters and some flat plains. And so this has been what people have discovered is that there seems to be a large amount of water ice accumulated in these dark, deep craters. This shows an average illumination. And so you have areas where the high parts near the South Pole have been in sunlight almost continuously for billions of years, and right next to them are these craters that have not seen sunlight for 2 or 3 billion years. And so it's once it was discovered that there was this accumulation of ice. Here you see the ice illustrated near the South Pole. That it's really interesting both scientifically and also as a potential resource. The scientific interest is that that it seems to have accumulated over billions of years, and that includes way back in the time when Earth's atmosphere was actually being blown off and accumulated in the polar regions of the moon, so that there's and also when you have impacts on the Earth, it can actually throw up material that is then lands on the moon. And so there's potential, if you look in the very deepest basins, there may be some indications of material that has been captured there and held in deep freeze since the origin of life on Earth. And there's also, there's even, speculation that there may be pieces of dinosaurs that have been held in deep freeze there. But so it's just a fascinating record of the history of the solar system preserved that way. Now, at the same time, there's, I mean, it's roughly 1 billion tons of water ice, and very similar in volume to the water that's in the Wellington Harbor, for example. And so all you need is take small samples of that, and you can split it with solar power into hydrogen and oxygen, and potentially use that as rocket fuel, as well as water to supply a lunar base. So there's science and the resource use interest. There's this map also shows, for example, some of the iron oxides and titanium that are on the surface and in other parts of the moon. And then most of the moon is oxygen, silicon, great for making solar cells, for example. It doesn't have that much nitrogen, so you may have to bring that for farming purposes. This is an illustration of the Shackleton crater. Is the rim of the Shackleton crater is actually the location of the South Pole, and so that the rim, the South Pole is located right on the rim here, and so you can see the sunlight model of how the sun is coming at it exactly horizontal, and so it's a very different kind of environment. This is a map of the temperature that is on the surface. So down on the equator, the surface temperature goes up to, in the daylight is 130 Celsius and minus 170 at night, with a long 14-day night. But near the poles, you can actually get some rather pleasant temperatures even during the day. But if you go into these craters, they're down at 40 kelvins or minus 230 Celsius, and so they're some of the coldest spots in the solar system, or inside these in these shadowed craters. If you wanted a more and nice temperature environment and radiation protection and things like that, you could potentially go into these, find these lunar lava tubes, which are billions of years ago, there were flows of lava and that caused these tubes and tunnels of lava to flow. And some of them have collapsed and other ones are intact. And so it looks like there are these tunnels that are up to 0.5 kilometer across that are potentially great places for building structures inside. It happens to sort of match this picture from the movie 2001: A Space Odyssey, where the lunar lander is being lowered into a tunnel here. Another thing that is different in the recent missions is that a lot of mission designers are now using this unusual gravity field of the Earth-Moon system with a 3-body environment where you can actually place objects in orbit around some of these Lagrange libration points, and so there are a number of missions that are orbiting these points in space in between Earth and Moon, or on the other side. And if people have discovered that if you use some of these this gravity field, you can actually get or reduce your energy to get to the moon by 25% or something, if you are very clever about it. It may take longer, it may take 1 or 2 months longer, but it's interesting how people are using the knowledge of sort of how to navigate, how to go through the environment in the cislunar space in order to be clever about reaching these things. And part of this is that the computing capability is much better now. So you can actually, the computations in the past, and when this was started in 1980s, was not, it was barely able to keep up with the time needed for the mission, but now you can do it, and your phone could do it. So some of the recent missions, the Chinese have had a very successful series of missions. They have had, they've landed on the far side, the only country to do that so far. They did a sample return a couple of years ago, and they're progressing steadily towards a human landing in 2030 or so. They have started to show how they might do a human landing with two launch vehicles that have and rendezvousing the crew and the lander in lunar orbit. There's a nonprofit group in Israel that attempted a landing and got very close, but just had a failure in the last 2 minutes of their just before landing. And this is a theme to remind us that landing on the moon is still a difficult challenge, and so each new group that attempts this has to learn how to do this. So there's Space IL from Israel. There's Japan. Earlier, they got. They also failed in the last minute or so. They got through all these different stages of their mission. It was just the last part of it that they failed, just with the software getting confused as they flew over the edge of the crater. And India earlier also attempted and had theirs fail in the last 2 minutes. So three missions have failed just in the last 2 minutes, just before landing. But India, just 6 days ago, has launched their next mission, and so it's on the way to the moon. And so they will try again. And they launch a combination of an orbiter and a lander, and the orbiters have been very successful. So good luck on the lander. Russia has been delayed, for years, many years, and is trying to reactivate their program, and may launch in just a few weeks with their Luna 25. We'll see if that gets launched. So with on the U.S. side, there's the U.S. has a very different approach. Is actually approved 15 different companies that will be able to bid for contracts to deliver lunar NASA payloads to the moon. And so it's part of this commercial lunar payload services set of contracts. And Astrobotic and Intuitive Machines have won a couple contracts, and this is an illustration of some of the missions that NASA has payloads that are contracted to go to the moon. And what's interesting about this program is that the NASA payloads don't take up all the capability of a lunar lander, and so the company is free to sell other space, other capability on that lunar lander to other commercial companies. So it's a conscious effort by NASA to take its funding and create a whole space economy focused on the moon, with companies that can provide services and also opportunities for commercial activity. This is another view of the initial missions towards the South Pole, plus other ones that are of scientific interest in these other targets areas. This is all within the framework of the NASA Artemis program, which is a return to the moon. And so we have Artemis 1, which is flown, is the uncrewed test of the Orion vehicle. Artemis 2 is planned. We'll have a crew that will go around the moon and test out the system. And Artemis 3 is planned to land humans on the moon, and later Artemis 4 and 5. And you can see little CLIPS landers popping up here, maybe 2 a year. So in order to accomplish Artemis, you need both the Space Launch System, the big replacement of the Saturn V using space shuttle parts. And you also, for the lander, the initial lander is going to be based on the SpaceX Starship, which is also undergoing testing. So here's Artemis 1 back in November, launched, was a test of the Space Launch System here. They had the Orion vehicle carried on an upper stage. And here's an image from the Artemis as it flew out beyond Earth and Moon. Unlike Apollo, it doesn't go direct to the moon to go in orbit. It actually flew around the moon and then back to the Earth again. So it's using some of the same gravity field tricks that I mentioned with the vibration points. But the Orion vehicle came back and was successful, so they're ready to put humans on to test it. Here's the rather complicated chart from NASA's plans of all these different elements of the program, with the target of Artemis 3 to land humans. It's described as 2025, but it's actually acknowledged as slipping somewhere in 2026. But it's also interesting that the first mission of Artemis program, Capstone, small satellite, was actually launched from New Zealand. And so this was a vehicle, a little spacecraft to test this special orbit that NASA will use later for the Gateway space station. So the Capstone is out in this orbit right now and performing successfully in this halo orbit around the moon. And a big difference between Apollo and Artemis is this first landing vehicle from base that SpaceX is building for Starship, with a Starship vehicle for a lunar landing. And also there are astronauts are training for this. I'm rooting for Jessica Meyer to be, she has a potential to be the first woman on the moon. And 20 years ago, she was, I was teaching her at the International Space University. But you can see that she's driving in a simulated lighting conditions of the lunar South Pole. The Apollo 11 was near the equator. Artemis 3 is targeting landing near the South Pole, which you can see are these funny looking shadows down here. And this is a simulated view from the South Pole with the sunlight coming out the edge, and the Earth just by the inclination of the orbit of the lunar orbit, the Earth sometimes disappears, which is why you need a lunar gateway to serve as a communication relay. And occasionally you'll get a sun being eclipsed by the Earth there. It's interesting that NASA has identified potential landing sites for the Artemis 3 mission. It also happens to overlap with the target landing sites for China. They are publishing their targets, and these are about 20 kilometers across. So there is space there, but the potential for interfering between landing missions. There's only one example of 2 missions landing next to each other, which was the Apollo 12 lander landing near the Surveyor 3, the robotic mission that had been there for quite a while. And when the astronauts examined the Surveyor 3, they found that it had really been sandblasted by the rocket exhaust from the kicking up all the regolith from the even though it was 160 meters away. And so if you have an Apollo that was like 6 or 7 tons landing and kicking up that much dirt, what happens if you have an 80-ton vehicle kicking things up? But this is one motivation for the Artemis Accords that note that New Zealand has signed the Artemis Accords that were initiated through US and NASA. And part of this is to coordinate activities on the moon and not interfere with each other by things like the landing near each other. And as well as the SpaceX Starship vehicle, the Blue Origin has won a follow-on vehicle contract for and their design it's interesting, is they uses hydrogen and oxygen, which potentially in the future could be refueled from lunar ice. And just this is an earlier version of the Blue Origin vehicle, but you can see that it's small compared to the SpaceX vehicle. It's interesting that some people have proposed even just tilting the SpaceX vehicle over and using it as a lunar base initially because of the sheer volume of it. So I'm going to talk a little bit about Starship because it is something that's on the critical path for human landing on the moon in the NASA plan. And so it has done hopping tests up to about 10 kilometers and was finally successful in landing, although it after a string of ones that blew up. SpaceX has a style of testing to destruction to many times over, that something that NASA does not tolerate really. But the next thing to test is Starship on top of the Super Heavy booster, and both of these pieces are supposed to be reused and be able to land on Earth. And it's interesting that their structure is, they actually have these things they call chopsticks that are planned to actually catch the vehicle while it's attempting to land, and so you can set it down. So it's just amazing what they're going to attempt to do, and they will try to do this very quickly in order to meet the schedule of NASA. This is just zooming in, showing the scale. But here's some of the record from April, from when they did a full up test of the Starship and Super Heavy with thrust that was, it's twice that of a Saturn V, and they managed to pretty much destroy their launch pad and send concrete flying and managed to knock out a couple of their engines even during the launch attempt. And so they had to completely redesign and rebuild their launch pad. But anyway, they did make progress in terms of, they didn't blow up on the pad. They managed to get, they even got through what's known as max Q, which is the maximum aerodynamic pressure, without blowing up. But then they immediately, they couldn't separate the two parts of the vehicle and managed to flip end over end 4 times and then blow up. You can see the pattern of the engines, that some of the engines have been knocked out by the flying concrete. So there, I'll just let it go to show the explosion here, which is, I do wonder if astronauts were watching this, but yep, there it goes. So so they are getting ready for another test pretty soon with their with the next set of vehicles. But the idea is that not only do they have to get the big vehicle into orbit, they also have to rendezvous and refuel it. There's not a lot of detail on the interior at this point for the landing on the moon, but this is one concept of the interior of the vehicle. And basically, SpaceX, the contract was to design a vehicle for that can carry 2 or 4 people to the surface of the moon, and they've designed a vehicle that can carry 50. And so it's just the illustration of the powers and the capabilities there. And so this is, if things go well, this is the idea. Let me see if I can. No, let me. Oh, this is okay. Let me just go ahead and show you departing from the Earth. This is after refueling. But the once again, it'll take you about 3 days out to the moon, but it would be rather comfortable in a large volume that's about like a 3-bedroom house inside. And the I guess I cannot advance like I was hoping, but so yes, you go around the moon into parking orbit, seeing the Earth rise and getting lined up for landing on the moon. This is also very different from Apollo days, where you're going to have high-speed communication throughout, and this is illustrating a final approach. Of course, everything is completely using rockets for attitude control. There's no atmosphere on the moon, so it's unlike the reentry on Earth, where you'd have to use the aerodynamic features of the vehicle. And let's see if we just coming in for a landing. This is an earlier illustration that showed that had the rocket engines at the base, and so we're kicking up a lot of dirt, a lot of regolith, and this is probably not what they want to do. And so sent in modifications to the design since this, they've actually moved the thrusters up to the middle of the vehicle. But this is an illustration of approaching a fully established lunar base. There in lunar tourism, even back after during the Apollo missions, there were Pan Am was taking reservations for future moon missions. Space Adventures, as we used to consult with them about the potential for flying around the moon using Russian vehicles. SpaceX is now selling flights around the moon. It's actually this Japanese billionaire has bought a flight around the moon with Starship, and has actually selected these 10 people to join him on this mission. And just as an example, how things could go quickly, this is, the number of people that visit Antarctica over the past, in the past decades, climbing up to 50,000 a year now. And so it's just, you have to picture the contrast between the tourists in Antarctica versus the early Antarctic explorers who just couldn't imagine that. So there's, it's interesting, so many different groups are working on lunar activities. There's, the NASA Lunar Gateway space station being designed and built to orbit the moon, European lunar base concepts, the NASA Artemis designs for pressurized rover and unpressurized. And you can see vertical solar rays because they're at the South Pole watching the sun go around the edges. The Chinese lunar base concepts, also vertical arrays for the South Pole, and they have ideas about communication pathways for all their elements. I mentioned the SpaceX lunar base concept. We have interior volumes that have been designed. You don't need stairs. You just jump from floor to floor, or you put on wings in order to fly around in the 1/6 gravity. And a big part of the motivation for the lunar material is it's great for making things like space solar power collectors that are collecting energy in space and transmitting them down to Earth without climate change effects. And in fact, even United Launch Alliance, Lockheed and Boeing is thinking that even just for their propellant depot, they need 1,000 astronauts on the moon. And then if you combine the lunar resources with asteroid resources, that's can fill in the gaps for certain materials that need to be involved. There's I wanted to mention the recent success of the University of Auckland Lunar Expedition for Everyone team, which is going through and getting qualified on using this lunar sat chipsets, which will be flying in the future to the moon and transmitting data back to the Auckland team. There's also some ideas about different aspects of the lunar base that could be contributed by New Zealand capabilities, like building solar arrays material or landing pads. There's lunar concrete being studied at University of Canterbury with aspiring materials. And there's cryogenic propellant management from Pavram, or food production, or and lessons from the Antarctic base. Every once in a while, NASA will say, we don't understand everything, which is, they should do that more. There's a big area that NASA needs help is food and nutrition and various aspects of how to support large activities on the moon. And so there's so many different elements of, the transportation to the moon may be, a factor of these big organizations, but everything else that's happening on the moon, from life support and habitats and mining and food production, they're all open for contributions from different people. And so we have things like, there's going to be a need for a huge number of robots and robotic activity on the moon. There's a need for manufacturing, 3D printing of capabilities and things like that. And food production, there's only a handful of places in the world that are looking at space food, and it's New Zealand has so much expertise in this area. And then there's things like spacesuits that are both interior and exterior spacesuits. So I think we're coming up on a point where there's going to be a huge surge of activity and involvement with many people around the world in going to the moon. And I think we're coming in maybe 15 years or 20 years, we're going to have friends who are on the moon, or else we know of opportunities to travel to the moon. And so I'll just leave with what the moon looks like tonight, which is if it takes 3 days to get to the moon, you want to launch. If you wanted to wait until sunrise happens at the target landing site like Apollo 11, today was be a good day to travel to the moon. So I think I will stop sharing. Thank you.
Thanks, Eric. So I think somebody has a question on the chat.
Oh, okay. Question: when they calculate the orbits, do they just use Newtonian physics, or do they use Einstein's general relativity as the nth degree of accuracy? Yeah, they start with Newtonian. is and it's a three-body problem, but then eventually they do fine tune it and apply the full general relativity. But I used to do trajectories for the moon, and it's really funny in a three-body problem that you can, if you're not careful, your little step size that you're optimizing, you can actually miss the moon, and so it's very sensitive. So it's gotten better over time, but you definitely need to take the rough approximation, and then once you've got a solid trajectory, fine tune it with the general relativity.
So if anybody else also has any questions, feel free to put it on the chat. We're also we're a small group, so you can also just like unmute yourself and just ask questions.
Hi, Eric. I'd like to ask a question. Noting, well, if you remember my interest in this, because noting what you said about the Chinese, that's quite concerning. It could actually wreck some of the heritage stuff up there, couldn't it? Quite badly.
Yeah, the question is, if you have an interest in preserving the first landings and first, missions that landed, and robots and things like that, how close can you get without disturbing them? Especially with these large vehicles, and that is it's a very interesting problem. It's not really solved. The Artemis Accords and some of these negotiations say you can't interfere with these others, but no one has defined how close can you get without interfering. And so at least the first Google Lunar X Prize was actually going to give extra points if you actually landed close to an Apollo site, and then somebody realized that was not a good idea, and so they've changed their policy on across the board about please don't interfere with these other sites for historical purposes, and so. I think in the next few years, we're going to see someone define a keep out zone, but we don't know what that is at this point.
I wondered if the Chinese, without being paranoid, were doing it deliberately to annoy the Americans.
I don't know. I think it's sort of a common interest in the lunar ices at the poles, but I think there's enough room for everybody, I think. Okay, let's see. Yeah, NASA initially promoted the Lunar Gateway as a base for interplanetary missions. Actually, I think if you could assemble your Mars vehicle at the Lunar Gateway, I don't think it's a bad idea, because I had a student long ago who we studied. If you start in the high potential part of the Earth-Moon system up at the moon, and then come back and swing by the Earth, and on the way to Mars, you can actually cut your delta V needs from 6 kilometers a second down to 3.5 kilometers a second. So if you can actually do the effort of building up a base camp out at the moon, and then starting from there to go to Mars, it actually saves you a lot of energy, but that makes a lot of logistics challenge in assembling your Mars vehicle up there. So it's still a trade-off that has to be conducted, but energetically it's not a bad idea. Yeah.
What do you think about society's tolerance of risk to human life now compared to back in the 60s?
Yeah, I think that's always been a big issue. I think that was why, for example, the Apollo missions were stopped, just because the the politicians realized that, you know, if they just kept on going until somebody died on one of these missions, that it would just be negative all around. And so they had actually built the vehicles for Apollos 18, 19, and 20, and they just decided not to fly them. And that's why they're Saturn V's lying on their side at the various NASA centers. But and so I think you're going to see the same kind of conditions here. And it's what's interesting to me is whether or not there's a difference between the private launches versus the government funded ones, and whether or not you know, if the Japanese guy and his collection of friends, if they die, you know, is that going to shut down a program, or is it going to be considered like a billionaire stunt? And so it's a real interesting issue, because there's you know, if you look back at the early days of aviation, there were a huge number of accidents. You know, there were just and people were just sort of like shrugged their shoulders and continued on. And so I don't know. I think you're right that the tolerance of risk on these big adventures is way lower than we have in the past. But I think, you know, at some point we're going to be seeing more accidents, you know, for sure. And so I'm concerned about some of these suborbital flights and things like that. So we'll see what happens. Yeah.
A follow-up question. Do you think it could be something to start the discussion before these flights start to happen, to manage public expectations? So if something does go bad, it's not terminal for the program, sort of thing. It was discussed previously, sort of thing.
Yeah, I think that's I think we do need to talk about this more. I mean, it was I worked on the lessons learned from the Challenger accident, and then also from was sharing information with the Columbia accident investigation. But those things, you know, they shut down the shuttle program for about 2 years, but there was a recognition that the shuttle was needed to complete the space station. And so the space station stayed in orbit and was waiting for the shuttle to restart. And in some sense, if you have a lunar base activity, if there's a failure of sending a crew, you may still have the lunar base and you still want to continue on with that. But I think, we're going to have more accidents, and we should be talking about this before we are reacting to something that's happened.
Thank you.
So I see that we're actually over the time already, but any other questions before we finish? Nope. Okay. Well, again, thank you so much, everyone. I know it's a Friday night, but we really appreciate everybody's presence and attendance. So great to see you. And we normally have similar types of webinars that are focused on space. So I hope to see you again in another session in the future.